Hi, this is Alex from devstories.eu. Deep Agents, Episode 12 of 16. Letting an AI write code is impressive. Letting that AI blindly run the code it just wrote directly on your laptop is a terrible idea. To fix this, you need a safe place for the agent to verify its logic without risking your host machine. That is exactly what we're discussing today, executing code in sandboxes. If an agent cannot execute code, it cannot verify if its code actually works. It relies purely on its training data to guess if a script is correct. Sandboxes give the agent a safe playground to iterate, fail, and fix errors based on a real execution output. Before looking at the mechanics, we need to clarify a common misconception. You might assume the agent itself must be deployed and run inside the sandbox. That is not the case. Deep agents rely on the Sandbox-as-tool pattern. The agent logic, memory, and prompts live securely on your server. The agent simply pushes shell commands in code over an API to a remote, isolated environment. This interaction happens through the execute tool. When the agent decides it needs to run a script, it calls the execute tool and passes the generated code block. This tool forwards the payload to a sandbox backend. Providers like Modal, Daytona, and Runloop supply these environments. They provision a secure container, run the code, and return the standard output or error logs back to the agent. The sandbox creates a strict isolation boundary between the execution space and your system. Consider an agent assigned to create a small Python package and run a test suite using PyTest. The agent sits on your server. It uses the execute tool to reach out to a remote ephemeral server. First, it sends a command to install required libraries. Then it writes the Python files into the sandbox directory. Finally, it sends a command to run PyTest. The sandbox executes these steps and returns the terminal output. If a test fails, the agent reads the error from the API response, updates the code, and calls the execute tool again. The agent can build, test, and wipe the slate clean, all while your host machine remains completely untouched. When you configure a sandbox backend, you must define its lifecycle. There are two main approaches. The first is thread-scoped. Here, the sandbox is tied to a specific thread. When the conversation starts, a fresh sandbox spins up. When the user session ends, the sandbox is destroyed. This ensures a clean slate for every interaction and is ideal for single-task operations where data does not need to persist. The second approach is assistant-scoped. In this model, the sandbox is tied to the agent itself, regardless of the active conversation. Every thread interacting with that agent shares the exact same sandbox state. If one thread installs a specific version of a library or downloads a large dataset, those files remain available for the next thread. This is the right choice when your agent acts as a persistent worker requiring a stable, ongoing workspace. Here is the key insight. The execution environment dictates the agent capability. By controlling the sandbox lifecycle and enforcing strict API boundaries, you give the agent the freedom to make mistakes without compromising your infrastructure. The true power of an agent is not just generating code, but iterating on failure, and remote sandboxes provide the only secure way to let that iteration happen automatically. That is all for this one. Thanks for listening, and keep building.